Hello everyone, my name is AVL and I work as application support for CRETA, an AVL tool for automotive parameter and calibration dataset management. In this video I would like to give you an introduction on the Outlier Detector feature. So what is the idea behind the Outlier Detector? As parameter management projects are getting more and more complex, dataset validation is getting more challenging as well. The goal of the Outlier Detector is helping the user to keep the parameters consistent in a global shared project. This task can be very time-consuming. Just imagine you must ensure that, for example, parameter B has to be always identical in all variants which have attribute Euro 60. How to ensure it? With the Outlier Detector, it is an easy task to define a pattern based on the used variant attributes and to create a cluster template file. With this template file, you can verify all upcoming datasets if the parameters are still consistently calibrated and that no variants are missed within the same attribute cluster right before the start of the production date. In short, Outlier Detector is a tool to help you in ensuring that the correct parameters end up in the right vehicle variants and controller. In this live demo, I will show you how to set a cluster template up in CRETA, then how to use that template for outlier analysis, and finally, I will introduce you the multiple revision compare functionality. First, I log in as the calibration or project pilot. On the left side, you can see the variant structure I use. You can see that there are many variants in the structure, and each of the variants has an imported revision, which by now had been merged once. So first I navigate to the Outlier Detector. You can find it under the Home tab. First I create a cluster template. You can use this template for future analysis as well. I proceed with the next button. I check if everything is okay. I will create my cluster template based on the original imported revisions. You can see that all of those are marked. I proceed with the next button. On the left side you can see the labels in the revision, and on the top of the table you see different numbers. Those numbers are the identification of each car variant. I will create my cluster template based on attributes. I know that my label A0 is sensitive to the train. Here we can see that each of the variants, so there are three different kinds of train types used in this project. The variant can be either all-wheel drive, front-wheel drive, or rear-wheel drive. My assumption is that the label A0, the future import, should equal in all all-wheel drive variants. And the same is true for all front-wheel drive variants, and I would assume the same is true for all rear-wheel drive variants. I know that my label A1 is dependent on the thermal management, whether if it's active or passive. And I expect that my label A2 will depend on the e-motor type, whether if it's actual or wheel hub. So with this information I will create my template. I mark these 3 labels with the outlier. You can find it in the drop-down menu. I save the template. So based on the attributes, you can see that variant 1, 2 and 9 are all front-wheel drive. So I would expect that the A0 label will be the same in all imported calibration. I assign the same number to all of them, all 3 variants. As I see, number 4 and 5 and 8 are all variants with rear-wheel drive, so I put them also to the same cluster. I use a different number this time. I repeat the same for the other 2 labels as well. So as you can see, I'm ready with my cluster template. I will proceed with OK. I save it. And I'm done with the template. So I can run the regression analysis to see if the right calibrations were imported to the right variants and they were merged to the right revisions. I again open the Outlier Detector window. I run the outlier analysis. As you can see, I will take a look at the revisions which already have calibration files merged to them. If I find everything alright, then I proceed with the next button. So in my analysis, the template was used which I created previously. You can see that the results are as expected because here the validation shows OK. This means that the calibration imports happened with accordance to the cluster template that you created. You can take a look. You can see the clusters appearing here. So I'm happy. So, as you can see, I merged the revisions under each of the variants once more. And I will perform the analysis, the outlier analysis, with the newest revisions once more. So I do the same steps again. I run the outlier analysis. The newest revisions are taken. Now you see that we found an outlier, which means the calibration import did not happen in accordance with the cluster template that was created before. So let's take a look. You see the outlier. Based on the attributes, number 8 variant should have So as the variant number 8 has actual emoter type, as all the other variants except of number 6, it was expected that the value A2 for variant number 8 would be the same as for all other variants with the same emoter type. As it was not the case, you can spot it that it's an outlier. And you can also see that under the validation tab, I just minimize some of the columns that you can better see it. That all other values are in accordance with the cluster template created, with the exception of this one. It is also worth doing a multiple revision compare. In this case, I have several merge revisions, but they are under the same variant. I do the multiple revision compare. Selected. Proceed with the next. I check if everything is okay. So I take all the revisions under the same variant. Proceed with the next. So this option is really nice to observe the history of each label. You can see that meanwhile A1 and A2 were only changed once. They were changed once and they stayed the same over time. The label A0 is alternating between the different revisions. That's suspicious behavior. If the value in each of the revisions had been different, all different, then you could observe here a different number for each value. It's important to mention that the number you see here does not equal to the actual value of the label in the actual revision. So thank you very much for watching our video on the outlier detector. In case any of your questions were unanswered, feel free to contact us. Goodbye.